In this video, we are going to start the new concept of our Laplace transform, that is the unit step function, beside unit step function and second shifting theorem. Okay, so let's proceed our discussion. What is the shifting theorem? Unit step function, unit step function or heaviside unit function, heaviside unit function. Okay, what we have done in a heaviside unit function, what we have to do, if f of t is Laplace transform of f of t equal to s, okay, then the unit step function, unit step function u t minus a or g t minus a or h t minus a is defined equal to 0 t less than a 1 t greater than. Okay, that is our definition. Now we have to find a Laplace transform of this. Now we have to find a Laplace transform of the unit step function. Now write down the Laplace transform of unit step function. Okay, we have to find a Laplace transform of unit step function. How to find it? Now we know Laplace transform 0 to infinity e s t upon f of t. Here we have 0 to infinity e s t, what, ut minus a into dt. So we have you have two functions, 0 when t less than a, t greater than a. So now we'll do by the property of integral. We can, by property of integral, we can you expand it 0 to a f of t, 1 minute, t minus u, I am writing here, e s t dt plus a to infinity f of t minus u e s t dt. Here ft, what is the value of ft? Ft is 0, so that will give 0. From we have to find a infinity, and what is the ft minus a? That is 1 into e s t by at. Now when we find it, that will give us, that is our Laplace transform 1 by s upon e s t a to infinity. When we will put infinity, that give us 0, that will be minus e s a upon s. So that is our Laplace transform. So write down it. So we have done the unit step function, and we have to move the forward. So write down it. We can move so that we easily move forward. Next, write down the topic of second shifting theorem. Or translational theorem. Okay, suppose what, if ft Laplace transform of ft equal to f of s, okay, we have Laplace transform of ft equal to f of s. So if we have a function and gt equal to f of t minus a t greater than 0, 0 t less than, then if ft equal to f of s, then Laplace transform of gt is nothing but eas upon f of t, okay, f of t or eas, where we have write it s, so we have to write it as f of s. So we have done the Laplace transform of the given function. Can we prove it? Let's prove our consequences what we have done. So proof, write down the proof. So we have done 0 to infinity est upon by ft dt. Now we know the Laplace transform of this. Now we have to find the Laplace transform of gt equal to what? 0 to infinity est upon gt dt. What? We can explain it 0 to a est upon what? est gt dt plus a infinity f of t, 1 minute, ast upon gt minus e into dt. Okay, now we have to find the Laplace transform of gt. gt is what? Now we have 0 to a, what? Now I am taking a, if a is greater than a, in case we have taken a is greater than a, when a is greater than a, so that in case we have a function t greater than 0 to infinity. Now we have the value of this. Now I am taking here t greater than a, so a est what? F of t minus a into dt. Okay, now 0 to infinity gt equal to t less than a, 1 minute. Can I use it? A2. Here we have understand the concept this step. What? We have 0 to a here. Okay, we have a range t greater than equal to 0. That means what? T, the value of t is lies between 0 to 0, less than 0 and in between it. So now we have to put here f of t. Okay, write down it, then we ast upon 1 minute. Okay, write down here. Here we have that will be 0. Or because t is lies between 0 to infinity, here with this is our 0, so 0, and that is f of t minus u dt. Now we will find 0 to infinity a to infinity est f of t minus u dt. Let t u equal to b. So how can I do this? dt equal to db. So t will be b plus u. So what do we get? When t equal to 1 minute. Yeah, sorry. That will our a. So that we have nothing but a. So what? We have a equal to t, when t equal to a, b equal to 0, and b t equal to infinity, b equal to infinity. So that will change our 0 to infinity e s b plus a s a f of u du. That give us f of s u u. F of s a 0 to infinity a s u into f of u into du, which is our e s u f of u. Okay, we can find a Laplace transform of u. That is our proof. So we will do the next concept question based on this theorem in the next video. So till then, watch the video, subscribe, share, follow, and thank you for watching.